Hi, I'm Benila. In this video, I'm going to talk about the power grid. I'm pretty sure that every one of us has some experience with shopping in Amazon. When you receive your product at your doorstep, have you ever wondered what was the journey this product has gone through? Let's just say that I ordered this pen from Amazon. First and foremost, this pen is manufactured in a company and it is shipped to Amazon stockrooms. The Amazon van picks up this pen from there and drops it in my doorstep. All the delivery systems work in a similar way, including our electricity delivery. But there is a slight difference in electricity delivery. The pen is manufactured long before it is shipped, but the electricity is transmitted instantly as it is generated. The electricity generated from the power station is delivered to our home through transmission line. Normally, these power plants are located far from the people those use electricity. For example, wind plants are constructed where the wind is strong and most consistent. Most thermal power plants are built near large rivers, lakes, or seas to get easy access to cold water. That means massive amount of electricity need to be transported long distance. This whole interconnected network designed to provide electricity all the way from its generation to the consumer is called the power grid or electrical grid. The journey of electricity begins in power plants where it is generated from thermal, wind, hydro or solar energy. The generated electricity is transmitted through power lines or transmission lines. The manufactured pens were first shipped to Amazon stockrooms. From there, it is distributed to consumers. In the same way, the generated electricity is first transmitted to substations and from there it is distributed to the consumers. The power lines are generally made of aluminum, which is a conductor. When current flows through a conductor, some power is dissipated as heat. When current increases, the heat dissipation also increases. That is, the power losses increased. This power loss is proportional to the square of the current, which means even a small increase in current can tremendously increase the power loss. And again, the power loss depends upon the length of the conductor. As power lines are very long, it will definitely increase the power loss. Power loss is not a good thing. We don't want to waste any of the power that we generate. We can't completely eliminate the power loss, but we can definitely reduce the power losses. We know that power loss depends on the current and the length of power lines. So if we reduce any of this, we can reduce the power loss. We can't reduce the length of the power line. Why? In this modern world, electricity has become one of the most essentials in life. It is very important that electricity needs to reach each and every household, hospitals and other buildings, even that which is in a remote area. So, compromising the length of the power lines is not a wise decision. Therefore, we need to concentrate on reducing the current. In order to reduce the current, voltage should be increased. That's why electricity is transmitted at very high voltages. It reduces the power loss which occurs in long distance transmission. High voltage is achieved through power transformers. Step-up transformers convert the low voltage and high current input to high voltage and low current output. The electricity generated from the power plants is first transmitted to step-up substation where the step-up transformer raises the voltage. As a consumer, we cannot use this high voltage electricity. All our electrical devices may even burst into flames if an overvoltage is delivered to the circuit. That's why before delivering it to the consumers, the power is transmitted to the step-down substation where the step-down transformer converts this high voltage to low voltage. Some of the power is tapped from the substation line to be used for industrial purposes. The rest is transmitted to the distribution substation where the voltage is again reduced. This is the final stage in the delivery of power. Primary distribution line carry this medium voltage power to distribution transformers located near the consumer's premises. Distribution transformers again lower the voltage to the utilization voltage. You will be able to see the distribution transformers near your neighborhood. Transmission towers support the high voltage conductors of overhead power lines. These power lines can also be buried underground to make the power lines less susceptible to outages during high wind thunderstorms or heavy snow. As the need for renewable energy is increasing, engineers are trying to generate renewable electricity in all possible ways. Some unconventional methods include floating solar panels, offshore wind turbines, and ocean thermal energy conversion. In all these cases, the generated electricity is transmitted to the substation through submarine power cables. Under normal operating condition, everything is safe and under control. But when a fault occurs, it causes excessively high current to flow, which causes damage to equipment and devices. In such cases, when fault is detected, circuit breakers are used to automatically break the circuit and isolate the fault in the system. Along with the transformers and circuit breakers, the substation will also have switches, bus bars, lightning arresters, capacitors, and many more components. Now, you might understand how big and complex this power grid is. Yes, the power grid is a massive machine. Today, most power grids use high voltage alternating current for transporting power over long distances. We have already discussed about the power loss in the transmission line. I have also mentioned that high voltage transmission is done to reduce the losses. However, high voltage DC transmission can have half of the losses of AC. DC transmission can be achieved by using AC to DC converter in the sending end and DC to AC converter in the receiving end. As I said earlier, the electricity is transmitted instantly as it is generated. What happens when the electricity is generated more than the demand? We need to store the excess electricity. But the problem is we don't have such a giant battery. As of now, the largest form of energy storage is through pumped hydropower plants. Do you know how it works? If you are interested, check my video on hydro energy, where I have explained this pumped storage very clearly. I have lots of interesting videos coming up, so make sure to subscribe and click the bell icon. Bye, see you in my next video.